Welcome back. In this session, we'll continue with the discussion on DFT. Let's start. So, in the previous session, we solved some examples of DFT. Now, today, what we'll do, we'll have a matrix formulation of this DFT. So, before we proceed, let's revisit what are the expressions of DFT. X of k is summation n running from 0 to n minus 1 x of n e to the power of minus g to the power by n kn, right? Where k is 0, 1, 2, so on up to n minus 1. So this is the endpoint DFT of x of n. Now what we'll do today, we'll arrange the terms in a matrix form. So what we'll do first, we'll write it like this: Wn is power k and y. Wn, as I already told you, this is called the twiddle. This is called the twiddle factor, right? So let's suppose we want to compute the 4-point DFT. Let's suppose we want to compute the 4-point DFT of this expression. So what we'll do, we'll write first x of 0. X of 0 will be, let me rearrange the terms, that means I have only, so x of k will be equal to summation n running from 0 to 3 x of n w4. So this will be w4 now, is equal to n, right? So n is equal to 4, right? So let me expand the terms. So this will be x of 0. So this is x of 0, w4 is power 0 plus x of 1, w4 is for k when n is 1, x of 2, w4 is for 2k plus x of 3, w4 is for 3k. Substituting the values of n here. So that's what we are doing. Put k equal to 0, 1, put k equal to yes, right? So this is our expression. Now what we will do, we'll substitute the values of k. So when k is equal to 0, that will give us the first sample of this discrete Fourier transform. So this is x of 0, w4 is power 0, x of 1, w4 is power 0, x of 2, w4 is power 0, x of 3, w4 is power 0. So this is our expression 1. Now put k equal to 1. When k equal to 1, this will be x of 0 in this expression I'm talking about. w4 is power 0, x of 1, w4 is power 1, x of 2, w4 is power 2, x of 3, w4 is power k is 1, that's 3. So this is the second expression. Put k equal to 2, so this will be x of 0, w4 is power 0. You can check it, it doesn't change. It doesn't vary with the first term, does not vary with 2, x of 2, w4 is power 4, x of 3, w4 is power 6, 3 multiplied by 2 is 6. Please pay attention to the terms. X of 3 is x of 0, w4 is power 0, x of 1, w4 is power 3, x of 2, w4 is power 6, plus x of 3, w4 is power 9. 3 into 3 is 9, so this is 4. So these are our 4 This is our 4-point DFT. Equation 1 contains x of 0, equation 2 contains x of 1, then k is equal to 1, same way equation 3 contains x of 2, equation 4 contains x of 3. Now what we will do, we'll arrange these terms x of 0, x of 1, x of 2 as a matrix. What we will do, we'll arrange these as terms as an array. So this will be x of 0, x of 1, x of 2, and x of 3. You can see these terms x of 0, x of 1, x of 2, x of 3 appear in all the 4 expressions. You can check it. Oh, look, these appear in all the 4 equations. So first let me arrange these terms. So this is W4 is for 0, W4 is for 0, and W4 is for 0. So this is also W4 is for 0, this is W4 is for 1, W4 is for 2, W4 is for 3, W4 is for 0, W4 is for 2, you can check it, W4 is for 4, W4 is for 6. So let me tell this. Then this W4 is power 0, W4 is power 3, 4 is power 6, W4 is 9. Then I will write the terms of the given sequence on this. So this is the matrix formulation, 4-point matrix formulation of DFT. So this is the 4-point matrix formulation of DFT. Now we can simplify it further. We can simplify this expression further. What we'll do, we'll evaluate what is W4 is power 0. We know W4 is e to the power of minus j 2 pi by 4. So this is e to the power of j pi by 2, right? So if we take W4 raised power 0, that will be e to the power of minus j pi by 2 raised power 0, that's equal to 1. Anything raised power 0 is 1. Same way W4 raised power 1 means simply e to the power of minus j pi by 2, and you can say check this is minus j. This is minus j. Why? Because if we use the Euler's identity, this will be cos pi by 2 minus j sine pi by 2. So this will be 0 minus j times 1 minus j. So taking the power of this will be minus j. And W4 is power 2 is same as minus j square. J square means multiply j twice, that will be 1. Same way W4 raised power 3 is minus j cube. Minus j cube. So that will be again equal to minus j. Please check it. Done it right. It will be minus j minus j. So this is minus this, and this will be. So I think it will be plus j. Plus j, I guess. I done it right. I think minus 1. Yes, this is minus 1. Right. So this is plus j. Please check the terms. So this will be W4 raised power 4. 4. This will be simply 1. W4 is power 6. You can take 3 raised power 6. How much is that? This will be minus 1 again. And W4 is power 9. Please check it. This will be minus 3 raised power 9. Minus 3 raised power 9 is plus. So this will be cube whole cube. Equal to 9. So this is equal to plus j. When you put cube on this will be minus j. Please check the terms whether I have done it right or wrong. Now substituting these terms here, we'll get this 4-point DFT of this x of 0, x of 1, x of 2, and x of 3. Please check the terms yourself. W raised power 0 is 0, 0, 0. Sorry, not 0, 1. Not 0, but 1, 1, 1, 1, and 1. And you will see the first column is also equal to 1, 1, 1. Because we have W raised power 0 everywhere on this first row and first column. Then it is W4 raised power 1. W4 raised power 1 is how much? Minus J. I think minus J, yes. Minus J. Then W4 raised power 2 is 1. Then minus 1. Sorry, minus J. W4, it is plus J. It is plus J. Yeah, it's plus J. So this is W4 raised power 2 is minus 1. Then it is J. Then it is W4 is for 4. How much is that? It is 1. Then minus 1. This is again minus 1. Then this is minus G. Then x of 0, x of 1. These will be given to you. X of 2, x of. This is your sequence. All right. So this is the 4-point DFT arranged in a matrix form. This is the simplification of this formula. This is the simplification of this formula. Now you'll see quite often this formula is written like this. This formula is written like this. X of k is written as W n x of n. This is written like this. What is this Wn? Wn stands for this array. Wn stands for this array, and this can be n-point DFT, and this can give you any n-point DFT where the matrix will have size. This will be n cross n matrix. So this will be an n cross n matrix. So W will stand for an n cross n area matrix there. Right. So in the previous example, in the previous session we solved this. What is that example of a constant, a delta sequence? Let me start with this delta sequence. When x of n is delta sequence, and we want to compute the 4-point DFT, right? We add the zeros ourselves. Then the 4-point DFT of this using this expression will be simply x of 0, x of 1, and x of 3. Write the terms 1, 1, 1, and 1. 1 minus J, 1 and plus J, minus 1, 1, minus 1, and minus J. Then it is 1, 0, 0, 0. Now check the terms, do the matrix multiplication. It will be 1 plus 0, 1. So this is always 1, 1. So that means x of 0 is 1, x of 1 is 1, x of 2 is 1, x of 3 is 1, and x of 3 is 1, right? And same way we solved the example of a constant. N is a constant. X of n is 1, 1, 1. Right. Now in this session, what we'll do is please substitute, get the values yourself. We'll do the next example. We'll say x of n is 1, minus 1, 1, and minus 1. We'll do this example. So we know from the matrix formula, arrange terms like this. So we can write it like this. So this is 1, 1, 1, and 1, 1, 1, minus J, 1 plus J. I hope I'm right. And here, this is minus 1, 1 and minus 1, J minus 1 and minus J. Then the values of x of n are 1, minus 1, 1. I'm using this expression, rather this one. All right, so do the matrix multiplication. Let's do the matrix multiplication. This will be 1, minus 1, 1, and minus 1. Then this will be 1 plus J plus 1 minus J. Please check it yourself. Please check the product yourself. 1 plus 1 plus 1 and minus 1 plus 1. This will be plus 1 plus 1, right? Then 1 minus j minus 1 and plus j. I hope I'm right. Right, so the terms will be, so this is 0, first term is 0, and then this is 2, then this is 4, this is 0. So that means x of k is 0, 2, 4, 0. Please check the result yourself. Do this example also in MATLAB, means type FFT of 1 comma minus 1, 1 comma minus 1, and check the result yourself. All right. Now, so this is our using matrix formulation, and if you know this, the computation becomes very easy. So what we have got here, we said x of k is simply wn x of what's wn? This is an array of the terms, and in general, let me write the general expression of wn. Remember, general x for any order of n. Wn is like this array. It will be w raised power 0. It will be always 1. So let me write. So this will be n minus 1 of term. This is 1, 1, and so on up to 1. First column and first row will always be equal to 1. Then this will be wn raised power 1, wn raised power, n 2, so on up to wn raised power n minus 1. Remember that. This is this term. So this will again be wn raised power 1, so on up to wn raised power wn raised power n minus 1. All right. So this is wn raised power 4, so on. This will be wn raised power 2 into n minus 1. And this, if you continue this, this will be wn raised power twice n minus 1. And so on. If you continue this, so this will be wn raised power n minus 1. These are the power. So this is the general wn matrix. This is the general wn matrix. And if you want to compute 4 point, 8 point, 16 point, 32 point DFT, just substitute the values of wn. You will get the this. And where wn, remember this wn is, e to the power of j 2 pi by n. So this is when you have to compute x of k using the matrix formulation. You do something like use the two-idle factor, and you get the value. So this is how these are related. Now, what if I have to compute x of n? I'm not right, but please do it yourself. So if I have to compute x of n directly, I will use. So see, it will be 1 by n wn conjugate transpose. So this is conjugate. Star means conjugate transpose of. That's what you will get directly. You will write it directly. So what you have to do now, what's wn conjugate? It is simply the conjugate transpose of this array. This is the conjugate transpose of this array. Remember, what is wn star? Okay, please do it yourself. Try to compute the 4 point and this x of n. 4 point. If w x of k is given, 4 for 4 points. For n equals 4, compute x of when x of k is given. All right, let me end this session here. Now, first, before I let me give you one assignment. Let's suppose x of n is 1, 0, 0, and 1. Second assignment is 2 minus 1, 2. Please do this. Compute the 5 point DFT of this. 5 point DFT using matrix formulation. Remember that. Compute the 8 point DFT of this. Right? But only 4 points are given. How will you do that? All right. let me end this session here. In the next session, we'll continue with the discussion on DFT.